Hello, everyone, and welcome back to Vinrays Academy. This is Vinay. Today, we're exploring a topic that's essential for anyone working in AI or quality assurance: best practices for testing AI and machine learning applications. Testing these applications is more complex than traditional software testing due to the learning processes involved, the variability of data, and the unique challenges posed by evolving models. In this video, we'll cover everything from validating model performance to handling data quality, testing for bias, and more. By the end, you'll have a solid foundation to implement best practices in your own AI projects. So, let's get started. Testing AI and ML applications brings unique challenges that go beyond typical software testing. Unlike traditional applications where inputs and expected outputs are predefined, AI models produce outputs based on complex learning patterns in data. This unpredictability means that testing must account for the fact that models evolve over time and are sensitive to the quality and characteristics of the training data. Additionally, AI models are probabilistic rather than deterministic. They don't give a single correct answer every time, but instead give results based on likelihoods. This requires ongoing evaluation, different metrics, and even unique testing methods to verify reliability. Understanding these differences is key to ensuring that AI applications function accurately and ethically in real world settings. High quality data is foundational to successful AI applications, as it directly influences how models learn and perform. A model trained on biased, outdated, or irrelevant data will fail to deliver accurate predictions or insights. Data quality involves several aspects, including cleanliness, balance, relevance, and representativeness. Clean data means no errors or outliers that can skew the model's learning, while balanced data ensures that all categories are equally represented to avoid biases. Regular audits of the data pipeline can help catch these issues early. For example, in a language processing model, biased training data can lead to discriminatory language generation. Thoroughly testing data quality helps ensure the model's reliability and fairness, preventing issues down the road. When testing AI models, accuracy is essential, but it's equally important to consider metrics like precision, recall, and the F1 score. Precision shows how well the model correctly identifies true positives without producing false positives, while recall measures how well it captures all relevant instances. For applications with serious consequences, like medical diagnosis or fraud detection, precision and recall are crucial. Testing teams should review all these metrics regularly and adjust them as needed. For instance, in fraud detection, we need high recall to catch all potential fraud cases, but also high precision to avoid flagging false cases. Balancing these metrics ensures a comprehensive and accurate model evaluation that can be trusted in real world applications. Edge cases are critical in AI testing because they reveal how a model performs under unusual or rare conditions. These cases might involve extreme values, unique combinations, or outliers that are less common but still plausible. For instance, a model designed for financial predictions may perform well on average income ranges, but might struggle with predictions for very high or low income levels if it hasn't been trained on these data points. Edge case testing ensures the model can handle various inputs and perform reliably. QA teams should incorporate these scenarios from the beginning, adding new edge cases as the model is updated. Robust edge case testing prepares the model for a wider range of real world situations, building resilience and user trust. Testing AI applications for bias is essential, particularly in fields where the consequences of biased outputs can be severe. Bias in AI can manifest as gender, racial, or socio-economic discrimination, often stemming from imbalanced or non representative training data. Bias testing involves analyzing model outputs across different demographic segments and checking for any patterns of unfair treatment. For instance, a hiring algorithm should give equal opportunity to candidates regardless of gender or ethnicity. Regular bias testing, coupled with careful data collection practices, can mitigate these risks. Fairness testing tools are available to help automate this process, allowing QA teams to detect and address biases early, ensuring ethical AI practices. Cross validation is a powerful technique in model training where data is divided into multiple subsets to validate the model's performance thoroughly. This process reduces overfitting, which is when a model performs well on training data but poorly on new data. For effective testing, it's also vital to have an independent test set, a data set completely separate from the training and validation sets. This ensures that the model's performance is truly generalizable. For instance, if we're training a model for speech recognition, cross validation can ensure it performs well on diverse voices and accents. Comprehensive validation through cross validation and test sets gives confidence that the model will perform consistently in real world applications. AI models are often integrated into applications that require real time responses and need to handle large volumes of data. Performance testing assesses the model's response time and resource efficiency under various conditions. Scalability testing goes a step further, evaluating how the model behaves when user demand or data volume increases. For instance, a recommendation engine on an e commerce platform needs to provide results instantly, even during peak shopping seasons. Performance and scalability testing ensure the model can handle these demands without compromising speed or user experience. It's crucial for the QA team to simulate high load conditions to confirm that the model remains responsive, fast, and reliable. Explainability is a key concern in AI applications, especially in sectors where decisions impact lives or finances. Explainability tools such as LIME or SHAP help to break down how models arrive at specific outputs, making it possible to understand the factors influencing decisions. For example, in a healthcare application, clinicians need insight into why a model suggests a particular diagnosis. Explainability testing helps in documenting and communicating model behavior to stakeholders, making it easier to trust and understand. Transparent AI fosters user trust, especially in applications where decisions have a significant impact on people's lives. AI models require continuous monitoring and testing, even after deployment, as they may encounter data shifts or changing patterns. Monitoring tracks model accuracy, performance, and even biases over time, alerting the team if issues arise. For instance, in a weather prediction model, changing climate patterns may affect predictions. By setting up automated alerts, QA teams can detect performance degradation early and retrain the model as needed. Continuous testing after deployment ensures that the model adapts to new data trends, maintains accuracy, and continues to deliver reliable predictions, improving user satisfaction and trust. Documentation is essential in AI testing, especially when models are complex or operate in regulated industries. Detailed records of test cases, metrics, and results provide traceability and accountability, ensuring a clear understanding of how models have been validated. In healthcare or finance, thorough documentation helps meet industry standards and regulatory requirements, providing a compliance trail. Documenting each stage of testing and recording any model changes helps QA teams improve over time, fostering transparency, meeting compliance, and offering a historical view for future improvements. In conclusion, testing AI and ML applications requires a well rounded approach that covers data quality, accuracy, performance, scalability, and fairness. Following these best practices helps create reliable, ethical, and user friendly AI models. Continuous testing and monitoring ensure that models adapt to evolving data patterns and real world needs, making them more resilient over time. Thank you for watching this comprehensive guide on best practices for testing AI applications. For more insights on AI, machine learning, and quality assurance, subscribe to Vinrays Academy and stay tuned for our next video.